Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abdul Mulik bin Baharin, matric number 19109028. And today I would like to present about the introduction for my project, Enhancing Power System Protection in Wind Farms. So, power system protection has evolved from primitive and unreliable apparatus to modern, complex, and reliable devices. Digital microprocessor-based protective relays have replaced mechanical relays in smart grids and microgrids due to their sensitivity, security, coordination, and extensive communication capabilities. However, their high cost pose a challenge, especially for large-scale wind farms. Overcurrent protection and coordination in wind farms with intermittent wind speeds is challenging. Limited research has been conducted on implementing costly differential protection relays for wind farms. To address this challenge, this study presents a cost-effective and robust method using the FPGA-based digital differential protection relay, which offer advantages such as lower cost, faster operation, minimal delay, and efficient processing of digital data. So the proposed relay is given to the detrimental effect of wind speed variation. Experimental validation using the FPGA DE2115 board demonstrates the FPGA DDPR fast reliable fault isolation capabilities. For the problem statement, wind farm protection is a challenge due to extreme wind speed and faults. Traditional relays are unreliable due to wind farm dynamics. So, microprocessor-based relays with extensive communication are a potential solution but are costly and vulnerable to communication failures. This research aims to design a cost-effective and reliable differential protection relay using FPGA technology. Experimental validation of the FPGA DDPS demonstrates successful fault detection, trip operation, and resistance.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazrul bin Sabri and my matric number is 191061, and I will continue the presentation with my part, which is about the methodology of power system protection in the farm. Okay, before starting the method used in the system protection, firstly let me explain about the basic operational of the differential relay used in the system. Okay, differential protective relay are highly effective and dependable for safeguarding modern power systems against overcurrent. They offer superior accuracy and are immune to the issues typically associated with overcurrent and distance relay. As shown in the schematic diagram, a differential relay detects faults by comparing the measured currents at different locations in the network. If the difference between the measured currents on two sides exceeds a certain threshold, the relay will active, okay, indicating an internal fault occur. Otherwise, it will not operate. As a result, the relay would trip the corresponding circuit breakers, and thereafter, circuit breaker would isolate the fault section until the fault is clear. Okay, a field programmable gate array is a customized integrated circuit used for specific tasks. It offers fast performance and cost-effective solutions compared to microprocessor-based and digital signal processing units. The development process for a field program gate array based digital differential relay involve the following steps. Okay, for the steps 1, it's the most important and challenging step in the process is to design and code the relay. The relay main task is distinguish between internal faults occurring within the defined protection zone and external fault that happen outside this zone. When an internal fault occurs, the relay logic is programmed to be 1, indicating that the relay should operate and trip. On the other hand, during the external faults, the relay logic is set to 0, meaning that the relay should not react. To summarize, the relay logic is carefully designed and coded in the field programmable gate array, ensuring that it follows the prescribed behavior as described in this equation above.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Arif Kimrabi and my matric number is 191091034. And right now I will explain with you about the methodology. To test the effectiveness of the proposed digital differential protection scheme based on FPGA, MATLAB software is used to perform FPGA in the loop FIL operation. To simulate and evaluate the protection scheme, a wind farm model is created by using MATLAB Simulink as shown in the figure. The wind farm consists of 40 type 3 wind turbines with doubly feed induction generator DFIG divided into 4 clusters of 10 turbines each. Each DFIG wind turbine generator 1.5 VA apparent power at the power factor of 0.9, resulting in a total power of 60 VA provided to the utility grid by the wind farm. The wind farm is connected to the grid through a step-up transformer that increases the voltage from 25 kilovolt to 120 kilovolt and a 50 kilometer transmission line which is represented as a pi circuit model. Since the protection relay is designed in the FPGA, the FIL operation is conducted, also referred to as a relay in the loop RIL operation. This allows for the relay to function within the simulated environment. Thank you.
Okay, Assalamualaikum. My name is Karunadi bin Nazarul. I will continue on the results and discussions. Okay, so the effectiveness and the dependability of the protection scheme for a large-scale wind farm under various operating conditions are assessed through the testings of the proposed FPGA DDPS. The system is subjected to three different types of fault, which includes symmetrical three-phase fault as well as unsymmetrical faults such as double line to ground LLG or line to line LL and single line to ground LG faults. In addition, a total of three different fault resistance values were chosen, which is the zero resistance, commonly referred to as bolted fault, 10 ohms and 70 ohms. Furthermore, there are two tests that have been carried out, namely fault test and impedance test. Initially, the evaluation is conducted under normal operating conditions. In the absence of any faults, as anticipated, the relay does not identify any unusual events within the network, and the logic implemented in the FPGA-based relay remains at zero throughout the entire simulation. As depicted in this graph, which show the wind farm behavior and performance, where the upper graph is wind farm current and bottom graph is trip signal from FPGA DDPR. Next, another examination involves the analysis of internal faults with zero resistance that are occurring at the main step-up power transformer located in close proximity to the grid. So according to this graph, it can be observed that when a three-phase fault occurs between the time interval of 0.4 seconds and 0.9 seconds, the relay effectively identifies the fault and subsequently generates the appropriate trip signal. So as the aforementioned situation is replicated for LLG and LG faults, and the FPGA DDPR system responds without any error. As depicted in both of this graph, it is important to note that the LL fault demonstrates nearly identical behavior to the LLG fault. However, the findings for the LL fault are not presented in this study. Typically, protective relay exhibit sensitivity to current changes. So consequently, in fault scenarios characterized by high resistance, the relay ability to accurately identify the fault may be compromised due to insufficient current magnitude. This limitation persists even when the fault occurs eternally within the protected zone. So in the process of designing the FPGA DDPR, two additional inputs, namely pickup current and slope ratio, are incorporated. So by appropriately adjusting this parameter and selecting suitable value for each protection zone, the relay can effectively identify high impedance fault and initiate a trip action to isolate the faulty section.
Assalamualaikum, my name is Muhammad Zaimi Azlan bin Muhammad Zawi, number plate 191091036. So I will talk about the burden fault. The figure presented demonstrate that the presence of the high fault resistance leads to a considerable reduction in fault currents. In contrast, the to water fault where no resistance is present in both scenarios within the fault resistance value are 10 ohm and 70 ohm. The relay effectively detect the fault and it's the generation of trade signal to insulate the faulty section through the circuit breaker. On figure 1 and figure 2, it shows that wind farm behavior and performance of the relay during 10 ohm and 70 ohm on the live ground fault at the power transformer. Okay. Another one is figure 3 show if the relay successfully ignore a three-phase external fault on the wind farm collector line. So next is the conclusion. In conclusion, the efficiency and reliability of the proposed FPGA DDPS array for the protection of a large-scale wind farm has been carried and demonstrated to the testing that has been carried out successfully. The relay was able to detect fault accurately and produce the correct trade signal in a variety of fault scenarios, including symmetrical and asymmetrical fault. Even during high impedance fault, in which the magnitude of the fault was significantly reduced, the relay performance did not falter. It remained reliable throughout. Traditionally, the FPGA DDPS demonstrate the ability to differentiate between internal and external fault, currently ignoring external fault that occur outside the protection zone. This was made possible by the fact that the FPGA DDPS was designed. This result demonstrates that the FPGA DDPS is reliable, fast, and efficient. As a result, it is promising solution for ensuring the safe and stable operation of the wind farm system. Thank you.